3 days of supplies, 1 day of water. Mutiny isn't just possible, it's inevitable. The captain stands with his back to the desperate crew, gazing at the horizon. Then he turns, his face perfectly calm. By sunset, we'll be drinking rum ashore. This isn't bravado. In the 17th century, a promise like that was a promise of life. Water in barrels would spoil over months, becoming a breeding ground for dysentery. Rum was medicine. This man had no charts, no GPS, but he had something we have irrevocably lost. Relying only on the color of the water, the flight of a bird, and the direction of the waves, he performed navigational feats that seem like miracles today. This isn't magic, it's a lost science, a system for reading the world that was more reliable in a storm than our satellites are in perfect weather. And now, we're going to crack its code. This skill wasn't exclusive to pirates. Long before them, Polynesians colonized the Pacific Ocean by reading the map of waves and stars. It's as if we've forgotten how to read, while they could read a book written by the ocean itself. We will break down the 5 main tools from their arsenal. We'll learn how the North Star served as their eternal beacon, how a simple ocean swell told of land hundreds of miles away, and how the Viking sunstone, a crystal of Iceland's spar, allowed them to find the sun even through thick clouds. And we'll start with the most important tool, one that is available to each of us right now. Forget complex calculations. The first rule of a pirate: the sun is your greatest ally. Sunrise is east, sunset is west. At noon, when the mast's shadow is shortest, it points due north. These are 3 points of reference that can never be lost. It's a simple system that works without fail. The ship's deck transformed into a giant sundial, with the mast serving as its hand. They didn't need to wear watches, they were sailing inside one. At night, the sky became a map. The primary landmark, the North Star. It is stationary, always pointing north. Finding it is simple. Locate the Big Dipper, mentally extend the line of its 2 outer stars, and it will lead you straight to Polaris. To a pirate, this wasn't just a light, it was a nail hammered into the heavens. In the southern hemisphere, where the North Star isn't visible, they used the Southern Cross constellation as their celestial compass. They drew imaginary lines between its stars to find the south celestial pole, a feat that required even greater skill. Here's a quick test. Imagine you've just left the subway in an unfamiliar neighborhood and your phone is dead. It's a sunny day. Could you, right now, in 5 seconds, figure out which way is north? This exercise isn't about survival. It's about starting to notice the world again, just as they did. Type yes in the comments if you could do it mentally. They weren't savages, they had tools, not charts, but measuring instruments. A simple cross staff, essentially a stick with a crosspiece, allowed them to measure the angle of the North Star above the horizon. A sailor would hold the end of the staff to his eye and slide the crosspiece until its ends aligned with the horizon and the star. It was a celestial caliper. And that angle is always equal to your latitude. Knowing your latitude, you are no longer lost in the ocean. You are moving along an invisible line on the globe. But what if the sky was clouded over for weeks? What if a storm hid both the sun and the stars? At that moment, the pirates stopped looking up. They began to listen and to read the ocean itself. An experienced sailor could detect a change in wind direction just by the sound it made whistling through the rigging. Every rope sang its own note. When the celestial map disappeared, they began to listen to the music of the storm. Wind creates chaotic waves on the surface, but beneath them lives the swell, long, gentle waves born from storms thousands of miles away. In the open ocean, the direction of the swell is constant. If it's hitting the port side, it will continue hitting the port side for hours. This was a natural compass that worked in any weather. Imagine the wind waves or the noise of a crowd, chaotic and unpredictable. The swell, however, is the low, steady hum of a distant highway. Pirates knew how to filter out the noise and listen to this deep hum of the ocean, which always showed the way. When land was still beyond the horizon, the ocean itself would change color. A deep, almost inky blue signifies the abyss, thousands of meters deep. The appearance of a greenish tint was a sure sign. This was plankton and particles from the seafloor stirred up by currents. It meant land was near, shallow water. What pirates did by eye, NASA satellites do today with their ocean color radiometry program. They analyzed the spectrum of light reflected from the water using the most advanced computer available, the human brain. But let's see this not through the captain's eyes, but through those of a common sailor suffering from scurvy. For him, the water changing from blue to green wasn't just a navigational sign. It was the promise of fresh fruit, the taste of fresh water, the difference between an agonizing death and salvation. It was the color of hope. During the Age of Sail, scurvy killed more sailors than all naval battles combined, an estimated 2 million people from the 16th to the 19th centuries. The green hue of the water was literally the color of survival. The ocean could point the way, but where exactly should they look for land? To find the precise spot on the horizon, pirates used their most reliable spies, those with wings. They had read the ocean, now it was time to interrogate its inhabitants. The main rule: not all birds are equally useful. An albatross could soar over the ocean for weeks, but frigate birds or boobies were living arrows pointing to land. In the morning, they fly from land out to sea to feed. In the evening, they return home. If you saw a flock of these birds at sunset, you just had to follow them. The observation was even more nuanced. A bird flying in the evening with a fish in its beak was guaranteed to be heading to its nest to feed its young. A bird without a fish might just be looking for a place to rest at sea. This small detail could save days of travel. A floating palm frond, a coconut, a piece of driftwood. To us, it's trash. To them, it was irrefutable proof. The current couldn't have brought it from the middle of the ocean. Land was somewhere nearby, upstream. All that remained was to determine the current's direction and sail against it. Finding a mangrove branch was especially valuable. Mangroves grow only along coastlines, in salt water. This didn't just say, land is near. It said, a tropical coast is near. It was a calling card left by the shore. Even the sky offered clues. On a hot day, land heats up faster than water, creating stationary cumulus clouds above it. While the sky over the ocean might be clear, a lone cloud on the horizon often marked a hidden island. It was a celestial X on the map. Furthermore, the underside of these clouds could reflect the color of the shallow water below. A greenish reflection on a cloud indicated a lagoon. A white one, a sandy beach. They read not only the clouds but their reflections as well. Let's introduce a credibility scale. The North Star is a 10 out of 10. The swell's direction is an 8 out of 10. But a lone bird might be a 5 out of 10. It could be off course. Success depended not on a single sign, but on their sum. The captain mentally assembled this puzzle from dozens of unlikely clues. He was like a detective at a crime scene. One clue is nothing. But 3 clues pointing in the same direction form a theory. 10 clues are proof. His job wasn't to find the perfect sign, but to gather enough imperfect ones. But all these signs were merely course corrections. The foundation of their navigation was a relentless daily mathematical calculation they performed blind, the art known as dead reckoning. Many think dead refers to death, but it's likely a corruption of deduced reckoning. It was pure mathematics, not superstition. Imagine walking across a room blindfolded. You know where you started. You count your steps and remember the direction. That is dead reckoning. Pirates did the same. They knew their port of departure, and each day they calculated how far and in what direction they had traveled. The ship's log, where these calculations were kept, was the most important document on board, perhaps more important than the Bible. An error in the numbers wasn't just an inaccuracy. It was a death sentence for the entire crew, and the captain was personally responsible for it. How do you measure a ship's speed in the middle of the ocean? With ingenious simplicity. They would throw a log overboard. It was a simple wooden board on a long rope with knots tied at regular intervals. One sailor would count how many knots went into the water while another flipped a sandglass. This is where the unit of speed, the knot, comes from. The standard was remarkably accurate for its time. Knots were tied every 47 feet and 3 inches, about 14.5 meters, and time was measured with a 28-second sandglass. The number of knots that went overboard in those 28 seconds was exactly equal to the ship's speed in nautical miles per hour. A compass provided the direction, but that was only the beginning. The captain had to constantly make corrections for the crosswind pushing the ship off course, drift, and for ocean currents, the invisible rivers that pulled them aside. It was a constant battle against error. Every day, a new point was marked on a makeshift chart, their estimated position. Estimating drift wasn't a science, it was an art. The captain would look at the wake behind the stern, the ripples from the wind, the floating debris, and make an educated guess. This was where experience separated a good navigator from a great one. This system was brilliant but terribly vulnerable. A tiny error in measuring speed or direction over a day could turn into a deviation of tens of miles over a week. After a month, they could be anywhere within a radius of hundreds of miles from the point on their chart. Their main challenge was the problem of longitude. They could accurately determine their north-south position, their latitude, but they were sailing almost blind from west to east along their longitude. This continued until the late 18th century with the invention of the marine chronometer. They knew which street on the globe they were on, but had no idea which house. And it was here, when calculations became useless and the sky was silent, that the captain turned to his senses, to the instincts that have atrophied in modern humans. He would literally begin to feel the land. The math gave them a search area, a huge square on the water. But to find the needle in that haystack, they had to switch off their logic. They turned the entire ship into a single sensory organ. When the ship got close enough, the very air would change. It became more humid. The wind carried the faint scent of blooming vegetation or damp earth after rain. At night, you could hear the roar of the surf reflected off low clouds. These were the final, most reliable signs. Approaching the shores of Scotland, sailors could smell the smoky scent of burning peat from hearths dozens of miles away. In the tropics, it was the sweet, almost tangible aroma of flowers. This was olfactory navigation, navigation by smell. Imagine the pressure. Hundreds of lives in your hands. You've gathered all the clues, the color of the water, the flight of birds, the numbers in your log. But the final decision isn't made in the mind. It's born somewhere in the gut. It was more than the sum of knowledge. It was a deep, almost animalistic feeling for the world, a faculty born from years at sea. Today, cognitive science gives this a name, expert intuition. It isn't magic. It's the brain's ability to subconsciously process thousands of microsignals invisible to a novice and deliver a complete answer as a simple feeling. Land is that way. The captain's brain was the most advanced navigational computer on board. Let's return to our ship. Now we understand what the captain was looking at. He didn't just see a bird, but its species and flight path. He didn't just feel a wave, but the constant ocean swell. He didn't just see a cloud, but a marker over an island. His confidence wasn't a bluff. It was the result of cold analysis. He wasn't guessing. He was reading the final page of a book he had been studying for weeks, and his promise to the crew wasn't a gamble. It was the announcement of a verdict already delivered by nature. This art seems like magic to us. But what if its key principles could be applied today, in our own lives, to navigate the chaos of information? Their world was one of information scarcity. Ours is one of information overload. But the task remains the same, to find the right course amidst uncertainty. Let's extract 3 main rules from the Pirates Protocol. Rule 1. Find your North Star. In a world of information storms, you need at least one constant point of reference. A goal, a principle, or a value that doesn't change when everything around you is collapsing. Rule 2. Read the swell, not the waves. Learn to distinguish fundamental signals from surface noise. The modern thinker Nassim Taleb would call this the ability to separate signal from noise. Pirates were the first masters of this art. They instinctively understood that daily news, the wind waves, was just a distraction. The deep, slow currents, the swell, are what truly shape the future. And Rule 3. Gather living signs. Don't trust only big data and calculations. Trust the small details, random observations, and your intuition. Often the truth is hidden there, in the cracks of the system, but what ultimately played the decisive role in their incredible success. The ironclad system of daily calculations, or the captain's almost supernatural intuition, born from experience? This is the central question. Write just one word in the comments about what you think is more important, system or intuition. Let's see which side has more support. It's the eternal debate. What's more important, the map or the compass? A rigid plan or the ability to feel the direction? The left brain, responsible for logic, or the right brain, responsible for images and premonitions? Perhaps the most important thing they teach us isn't how to find land in the ocean, but how to find our bearings when it feels like there's nothing around but chaos. The captain stands on the shore. Next to him is a young cabin boy, and he isn't just watching the sunset. He's pointing out a flying bird, the shape of a cloud, passing on the knowledge. The art doesn't die, it is passed down.